All right, that took a while, but we are live now. Welcome back to AJC and the Web Devs. I stopped counting specific episodes. We're around like 20 or something now. We got my good friend, previous coworker, general web dev enthusiast friend, Ishan Anand. You were one of the first big champions of my podcast, FS Jam. I remember specifically how I met you. I was looking at the Jamstack Slack back when that existed, and someone's like, why aren't there like full stack,
Yeah.
Jamstack
Oh, no, I
things or
remember.
stuff
Yeah.
like that? And he's like, and you were like, you should check out this podcast. They talk all about full stack Jamstack stuff. And I was like, hey, that's my podcast.
Yeah, no, it was great to I was already a fan before I met you. And I thought the podcast was great. I listened to Jamstack Radio, of course, but FS Jam was like basically number two. You and Chris were really at the forefront of covering what was a growing movement. And it was just exciting to, you know, meet you and then actually work with you. So that was really great. I look back at that with fond memories.
Yeah, I mean, you did so much stuff in the Jamstack world and even built like a proto Jamstack platform. And now you're pivoting, or not pivoting, but you're very into AI right now, just like I am.
Yeah, I think it's very common. And what we're going to talk about with spreadsheets are all you need. Part of the audience for that is people like me. And that means two things. One is, people who come from maybe a technical background, but might be, product executives. So I'm VP of product currently, but have an engineering background, or people who are like have an engineering background in like web development or backend or infrastructure, and they're trying to wrap their heads around this AI thing. I think spreadsheets are all you need is a good introduction for that. It's the course kind of I wish I had when I was first diving headlong into this. And it's just a really fascinating space, and we're going to need a lot of AI engineers in that space. So we're going to need people who can blend that type of skill set with understanding of these AI tools and models. So I think it's a really important audience that I'd like to connect with as much as possible, like I was already doing, kind of in the Jamstack ecosystem.
Yeah, you're a very dev rally, dev advocate type stuff. Some
Yeah.
people I always say they like exude that naturally, even if they're like, a VP of tech or whatever job they do. So I've been super excited that you've been kind of also jumping into AI. And the thing you built is so interesting. I can't wait to get into it. But you were just at the AI Engineer World Fair, which was put on by Swix, and a good friend of mine, Noah, actually kind of like Swix's, I think, right hand man, I could say right now. And how was it? I wish I could be there. I missed it by a
Oh,
week, so
it,
I
it
was so
was awesome. Let me just spend maybe 2 minutes giving folks a little background about Edgio and what we did,
mhm.
or have done. Basically, I was CTO at Layer Zero. That was a Jamstack platform, but really focused on high-end websites. So we, rather than taking a static first, took a serverless first approach, where static techniques can apply. So our specialty was scaling Jamstack to large, high-stakes e-commerce sites. So customers include folks like Sharper Image and Mattress Firm. You've probably used, an Edgio at this point, powered experience, and may not even know it. And then we were acquired by Limelight Networks, and I became VP of product for our whole applications platform. What I like to tell people is it's kind of like if UPS or FedEx decide to get into the passenger airline business. They have the planes, they have the pilots, they know logistics. They need to just change the inside of the planes to, from strapping down packages to seats for passengers. And then they have
Just
to
don't
change
have
the fabric of
Boeing
the
do
car.
it.
Yeah, so Edgio or Limelight Networks is really focused on video, and they basically brought us an Edgecast in to build out the applications platform. So have the infrastructure, but run the software for serving apps. So people use Edgio for accelerating, hosting, and securing their high stakes websites. So like web application firewall, DDoS protection, CDN acceleration, and then Jamstack hosting. That was the applications platform. So that was kind of the Jamstack background, and web development background. To your question on AI engineer conference, uh, you know, uh, it was not only awesome, it's really unique. So if people are not familiar with this, first of all, we need to just back up. What is an AI engineer? Swix has this great essay. I recommend you Google it, "The Rise of the AI Engineer," and he has a great chart. Actually, what? Can we bring this up? Let's bring it up.
Yeah.
AI engineer. Rise of the AI engineer.
You want a screen share it?
Yeah, sure.
Yeah, I think of Swix, what he's doing right now. It kind of reminds me of when Nader Dabit got into blockchain. He started Developer DAO, and because he was already like had such a huge following and like understood community, it was like instantly this huge community flocks like immediately, and then just kind of goes from there. So it's been really exciting. 'Cause I was in his Discord before he got into AI, and
Yeah.
the Discord was originally for like tech finance stuff. Like it was all about like buying Cloudflare stock and stuff, and then it kind of slowly shifted to AI, and then he did it full time, and he does the Latent Space podcast with Alessio, and
Yeah.
Alessio built something kind of like Auto Show actually for this.
Oh, interesting. I didn't realize that.
Mhm.
So, here's the key diagram, right?
If
Which
you
is basically, can you see it? Yeah, let me
zoom in
zoom.
a couple,
Yeah, there you go.
that's good. Yeah. Mhm.
So, you've got your classic machine learning researcher here on what is my left. Hopefully, it's yours as well. Never know if the video gets rotated or
No,
swapped.
it's fine. You wouldn't be able to read if it was rotated.
Yeah, and then you have your product user constrained regular full stack engineer, and there's
Let
kind
me comment actually real quick on
of
this because this is like in a nutshell my journey trying to learn to code. I tried to learn to code in 2016 and started all the way on the left, having to
yeah.
learn Python and ML. And then I realized it was totally impossible. And I jumped to doing full stack JavaScript instead. And now I'm meeting it in the middle.
Oh wow, it's all coming together. So there's this role that is the person who's kind of sits at this API, and this is kind of like a bottoms up kind of what they do. But the way I like to look at it is, and I tell people like the gap between having a model and having an actual product is filled by the AI engineer. It's the
Mhm.
solution to this, problem where we've got some people saying these things are, you know, stochastic parrots, they're not useful, and other people saying they've got a ton of potential, you really need to use them. And I can think of like some of my favorite people in product and market analysis that are saying, these things are not useful or they're unreliable. And then there are plenty who are like, you have to try it. It's got so much use, even if there's no progress whatsoever. And really, the bridging of that is the AI engineer. Things like how do we take this and make it reliable? How do we make a real product out of it are super important. And this is really what engineers have been doing since time immemorial. The analogy I
Mhm.
like to use is, if you look at the average number of miles driven per day by somebody in the US is something like 42 miles. Um, that would
42
be
miles a day?
yeah,
Wow, that's terrifying.
yeah. So that would be impractical in 1888, or so, when the first gasoline automobile was built by Benz. That thing couldn't go
Steam
basically.
engine.
Well, it was gas. Well, steam engine was even earlier, but
I'll say
you
that's
know,
like that was the first big jump. And
yeah.
that's to me what LLMs are like a steam engine.
I would put LLMs as the gasoline engine, and maybe the steam engine was RNNs and all the pre LLM. Like, here's the thing that I think is going to take us a lot of the way, just like we had a lot of other things. So maybe electricity comes back, so to speak. Um, but like that would be impractical at the dawn, like of the gasoline engine. It couldn't go 10 to 15 miles without needing to be repaired or refueled, or even just new water in added for cooling because it would just evaporate out. So there's this famous story of Benz's wife, Bertha Benz, and she takes a 60-mile journey, and it's a publicity stunt because nobody thought, including Benz himself, thought it could actually go that far, and it even broke down during the trip, right? And she had to use, like, famously, I think her hairpin to repair it. Right? It was so brittle,
Sure,
it
it was
just
made
wasn't
up.
as
That has
reliable
to be a
as
made
it.
up story.
Pardon?
That has to be a made up story.
Well, okay, it was a
The
publicity stunt.
hairpin part is what I'm saying. That's just like is the type of perfect like media narrative story. And like I bet she had that with her. She's like, I'm gonna do this. Anyway,
Maybe
I get your metaphor, but
the
I find
metaphor is,
this
yeah.
funny because people always used to explain AI as like the difference between horses and cars, and this is a similar thing.
Well, yeah, that's another. That's actually another good analogy. But the point here is it's unfair to judge the technology a little bit by the reliability when it of a new technology the same way you judge something that's gone through 100 years. Now, because of the importance of this technology, we're going to have to very rapidly. We don't have 100 years to figure it out. But the point is that an AI engineer is a really important part of doing what we did to cars over the last 100 years, turn them into reliable, safe systems that people can depend on without having to have understand how they work. And so that's what I think, the industry and AI engineers are a really important part of doing. Getting
By
back
the
to
way,
the
this
conference,
is
I don't think there's any other place that I can think of. Well, there's maybe a few, but this is like the number one place where those two streams come together. There's plenty of machine learning conferences, and there's plenty of full stack or other conferences that might have little AI. But this is really about mixing the two and turning real products into them, and that's what makes, I think, the conference so unique and so awesome. So sorry, what were you gonna say?
Yeah, so I'll just say real quick, this has been my pinned tweet for about a year now. Pay less attention to what AI can't do, pay more attention to what it can do. I think this is the mind shift that people really have to make who are like really want to make the case that AI is like useless or this hype or like a fad or that's gonna all like go to zero because they will find these really specific ways it fails. And
Yeah.
so he's like, it can't name all the continents that start with the letter A. And I'm like, I don't care. I don't need it to do that for me. Like, it can write code. It can tell me what my error message means. Why would I care if it could name all the continents that start with the letter A?
Um, you know, I think it depends who you are and how you look at the world. Uh, some of the folks that I highly respect who have that kind of view are experts in their field, and so they don't need assistance in that area. And so for them, they use it, and they're like, "Oh, this
But
is
what if
this."
they want to push beyond their own abilities and the frontiers of the field they're in?
Well, where the data shows that these tools tend to be the most useful, at least in terms of as a co-pilot. There's a lot of ways they're useful, but is that
That's the
they
way
help.
people are using them. I don't think that's the same as it being the most useful. I think that's a qualitative thing that can't really be directly pinned down.
Well, that's true. We're still in the what I call the stage play era, which is so the let me explain the analogy. So the very first movie cameras were the movies were just stage
You love
play,
your historical
right?
analogies, and I love them
Yeah,
too.
because around the same time, right? People just what they knew, they reimagine the future in terms of the present. And it took a while for somebody to realize, oh, we can take this camera and we can move it around, right?
We can cut. You can cut from one thing to another.
And you can cut,
You
you can
don't just need to
edit.
film a stage.
Yeah, it doesn't have to be like a stage play. So we're still like looking at them in terms of, the jobs to be done. Like a great example is like social media. Like most of those jobs didn't exist before the field, was really born. And it was hard to predict a little bit, although some people did in say the early 90s. We haven't had the companies yet, or we're still waiting for, those synergies that'll come from a truly native AI first environment. Say like the Facebooks of the world. We're still kind of like Amazon was a bridge. I buy stuff, in a store, I buy it online, but the truly native to that medium, those are still companies that are yet to be formed, and I look forward to seeing them. But the point I was getting to is the the data is that an AI copilot, and usually we should be really precise in a second about what we mean by AI, is usually most helpful for people who are not yet experts. So what they found is that they can take somebody at the middle, at the lowest end, or at the highest level of performance. And what happens is the amount of increase for the highest level of performance isn't very high. But for people who are at the middle or low, it brings them up. It almost kind of unifies
Yeah,
and
I could
flattens
argue though
the
that
skill level.
someone who is an expert and knows really how to use it would be able to do the thing they can already do, but do it way faster because the thing can type like 1,000 words per minute. So I just feel like that the experts aren't being creative enough in how they're thinking of ways they could also utilize these tools.
I think there is potentially a lack of creativity. The one I'm thinking of is there was a really good article where he's like, I asked it to give me the background of some situation, some historical analysis. And it turns out it got like it 90% of the way, right? But it swapped the positions and the people who and the positions they were giving.
And that's where
Um,
the experts come in. They can get the 90% correct boilerplate with the 10% wrong and quickly
yes,
see that and
yes.
fix it.
Oh, and it also depends on your use case. Like we're talking right now about content generation. There's a bunch of use cases for these tools for things like writing code, which is
That's
verifiable.
what I use it for most.
Yeah,
I mean, I have this is the thing about auto show. I couldn't have built auto show without having models to use in it specifically,
Yeah.
because I can use it to generate the show notes. But I also, I mean, I could have built it without ChatGPT and Claude, but it would have taken me like 3 times longer because there's just a lot of things that I had to learn on the fly to build it because I haven't done a lot of like node scripting and stuff beforehand. I did mostly like front end stuff. So it allowed me to basically parcel out the different pieces of the project that I already knew I was going to have to build, or the things I would have to figure out. But it just like lets me short circuit so much of that. And it lets me have like a really, really fast iteration cycle of building features.
Absolutely. I used it in building spreadsheets are all you need for certain Excel formulas because I'm more used to Google Sheets. And I'm like, I know how to do this in Sheets.
It's a good
Yeah.
transition. What is spreadsheets are all you need?
Yeah, so spreadsheets are all you need is well, right now it's a course and a spreadsheet that teaches how large language models actually
Should
work.
pull up your screen
Yeah.
and show the
Let's see.
home page, which is awesome and has all these testimonials now from
Yeah, let's
super
pull it up.
legit people because you blew up online.
It did get on Hacker News. So
This
let's
is
see.
like this is catnip for Hacker News. It's like this really ridiculous nerdy project that is hard to actually understand why it's useful, but you can't have really snarky, rude things to say about it.
Yeah, so right now it's basically a low code or no code way to learn AI.
But
So what I
isn't
did is
Excel a programming language?
technically it is, but most people don't consider it that. So I used to call it low code, but
It's more of a programming language than HTML.
yes, I'll give you that absolutely. But there's plenty of people who use Excel, but they don't think of themselves as programmers. So I wanted to essentially broaden the audience. But if you want to be truly accurate, it would be called a low code way. Um, and so it's basically an implementation of, a large language model, and not just any large language model. It actually implements GPT-2, which is a early precursor to ChatGPT. So basically, ChatGPT is 2022. It's only about 3 years earlier. In the evolution, and it's basically the small version of it, the 124 million parameter one, but implemented entirely in Excel. So
I'm
it's
gonna give you a link real quick
uh,
to pull up. I'm going to the private chat. So this is this I wrote very briefly a couple blog posts in 2019 about large language models, and this is a moment where I can say I was ahead of the curve because I referenced GPT-2 in this blog post written in 2019.
oh, well, you want to share your screen and
Yeah.
bring it up?
So no, you should go to the studio
Okay.
and then click the link I put in the private chat. No, this is private, so you can just pull it up on your screen.
Oh,
It's
it
not an
will. Okay.
issue.
Let's see.
Yeah. It's called
Uh,
private chat, but there's nothing private in there.
okay, let's go.
And then
Oh, this
scroll
one.
down almost
Yeah.
all the way to the bottom,
Yeah.
and then right there, and then bump the font up a bunch.
Yeah, I see
So
it.
this was from Gwern. Do you know who Gwern is?
Familiar. I think I've. But I
He's
don't.
a non old school AI and crypto kind of researcher person. Can you bump your font up?
Yes, I can.
So he used GPT-2 to write poetry. And so it
Mm,
wrote this little poem that's kind of like about being a neural network and like understanding words and stuff. And like, some people look at this like, that's bad poetry. And I was like, hey, it is literally poetry and it's about something. The fact that a computer program was able to do that was completely mind blowing to me. It was like
I agree.
absolutely blew my mind. And I was like, this is going to be really, really important technology once it kind of grows. Because they did this and they did like Harry Potter fan fiction. Maybe that was GPT-3, but that was like not very exciting to people who couldn't see the potential. But then ChatGPT dropped, and I'm like, hey, this GPT thing finally blew up.
Yeah, the famous GPT-2 example was the unicorns article it wrote. So it wrote this article about discovering
Pull that up.
unicorns, and it was supposed to be a news article, and it did a very convincing job. Um, and so maybe what we should do though is help settle some definitions here. Um, so there's, and I should have a graphic for this, but I don't. There's AI, which we've been using for a long time. Before ChatGPT. And let's take for example like the ads you get served on your Facebook or X Twitter feed, right? Those are done by maybe a smart AI model. and it's using it through an application of statistics. And what's happened over the last, 4 or 5 years is we've suddenly got very good at applying statistics to generating text and analyzing text. And hence we get these large language models, which are a subset of AI and machine learning, that are taking things by storm, and it feels like they could pass the Turing test much sooner than I think any of us imagined, really. And so what Spreadsheets Are All You Need tries to do is explain to people of really as many backgrounds as possible how the entire thing works end to end. And in theory, so this is the spreadsheet. In theory, you could understand the entire model just by going, tab by tab through this spreadsheet, formula by formula. Now, there's like over 150 tabs. There's really about 10 to 15 that are the key functional ones. The rest of them are actually the so-called weights of the model. So maybe we should back up and just explain some basic definitions. So let's do this. It's odd. I'm going to be switching between PowerPoint and slides. But you've got a model, and normally with regular programming, what you're doing is you get some. Where's my text box?
This is your Scala draw.
Yes, this is exactly. So you have some
Suck on that, Theo.
data. Yeah. Some data that goes in like this, right? Goes into your program. And then you have some rules that you program, right? That's your program. And then you get your desired output.
This is how I know you're old school, because every diagram that I ever saw when I was learning computers was a series of boxes and lines pointing at other boxes, and I was always like, what the fuck does this mean?
Be thankful I'm not using the flowchart stuff, right? This is your classic programming. It basically processes input or data into output that you write. So this is the thing you write. In AI, we want to do the same thing, but we have this nice property that what we can do is reverse this process. Instead of having to write these rules by hand, we can now let the model derive this by basically feeding it the answers, right here, and the input. So if these are, I'll call this the data that you want to go in, and then it drives this instead of you programming it. So the only thing you're doing is you're maybe configuring and building the model. So AI
when I explain this to normies, the data would be pictures of cats and not cats, and the
Great
answer would be
idea.
whether it's a cat or not.
Yeah, so this is like pictures, and then cat or no cat, and you
or
write
hot dog, not a hot dog. Other
Yeah.
canonical example.
Yep, and then developer builds this, and then the model figures the rules out.
And it even does this for games. This is how AlphaGo worked. Like, it's not just that's what's so crazy about this paradigm.
To put this in perspective, so if you look at GPT-2 GitHub, this is what I did when I first, like, if you look at it,
the last model of our open source.
Well, never say never, but if you look at the model, it's not a lot of lines of code.
I've seen I think I saw a paper that showed how to implement a transformer in like 50 lines of pseudocode.
Yes, it's actually, I mean, I was able to do it in Excel. The hard part is really the scale and throwing the compute at it. So I mean, think about this. This is a program that
Can you parallel Excel?
You can just throw text at. Like, if you had asked me before I knew how LLMs worked, write a program that can have a conversation like ChatGPT can, I wouldn't have imagined it would be so small amount of code. But all the knowledge essentially is in the data, in the model itself, in what are called the weights. So let's go back to this, which is the spreadsheet. So this is our spreadsheet, and what you do, this implements a full model. So you'd say my cat is so this is the one Lifehacker, when they covered this, used. So I clear this out, and then you run. So here's the fun part. So most times when you use a spreadsheet, it automatically recalculates. I have to turn that off because this spreadsheet is so big.
I will lag.
Yeah, there's well,
like your
watch this.
TS server.
Yeah. Yeah, so you can see it's calculating, calculating, calculating. It's gonna take roughly about 30 seconds, maybe a minute. Let's see, with everything else in StreamYard running in the background, how long it takes. But it'll then get the next token completion. Let's see and then it's important to understand that what we've built or what's built in the spreadsheet is what's called a base model. So all it knows how to do is you give it a bunch of sentences and it tries to predict the next token. But it is not a chat bot. So creating a chat bot requires something that's referred to as reinforcement learning, often reinforcement learning with human feedback, where they basically condition the model to basically answer questions in a chat-like format.
And
Uh,
answer them in a socially appropriate manner.
Yes. Well, that's where you program in or condition it to say refuse certain prompts, like requests that could be dangerous or biased. So it's a really important part of how to make these models usable, reliable, and also safe. The common phrase you'll hear is helpful, harmless, and honest. So here it is. My cat
Yeah,
is
they're
sick.
not quite honest yet, but we'll see.
Well, they try. So this is your next token predicted. So the rough outline for how this works. So I'm going to put this back to Mike. Is
Can we
Yeah,
tangent real quick after you finish this section up?
yeah, go ahead.
So, what I really like about this is this kind of gets into there's this high level explanation of transformers. And I think with all deeply technical topics, there's like a single line high level explanation that usually will get people most of the way, but is fundamentally wrong in like really important ways that if you're not like, you don't have intellectual humility, you think you get it because you hear this like simple one line explanation, but you really don't because it's very misleading. So this is the explanation where it's just predicting the next word. Everyone
Yeah.
says that like it's just predicting the next word, so it's not actually doing anything interesting. Like it's true that it's predicting the next word, but that doesn't mean what people think it means.
Yes, that's a really good point. The idea is if you can predict the next word, you must have a world model of some kind to get a very accurate prediction for what the next word should be.
Mhm.
Um, so like this,
Like
for
the person
example.
who killed JFK was blank. The answer to that question is very important.
Well, yeah, but that actually is maybe to a certain extent trivial. That's a memorization.
No, it's
Uh,
not though, because the history books will tell you the wrong answer.
oh well, okay. Well, depending on, in theory, you could look at that as memorization. But what you can do is there's a great one from the Tiny Stories paper, and the sentence is, let's call it Jane wants a dog or cat. She asks her mom for a pet, and she says you can't get a cat. So Jane asks for So the answer is dog, right? But there's a couple things you'd need to factually piece together to figure out. Well, first of all, she wants, either dog or cat. You know that the word not was applied to, I can't remember what I said, cat. So the answer has to be dog. But there's a logic process that needs to go through that
Yeah, and like,
it
and I'm sure
wasn't
you know
trained
the
for.
example of
Yeah.
like the king minus woman or king minus man equals queen. That's another example they used to always talk about that they could figure out by
Well,
like
that,
by thinking about how concepts relate to each other in kind of like a vector space way. It requires you knowing what topics cluster together and which ones are adjacent to it and which ones are farther away versus closer. And that requires like some amount of world knowledge.
that's another example of world knowledge. What's interesting about that king minus man plus woman equals queen is you can get that result through just embeddings, which we'll talk a little bit about. But
Okay.
the ability to go and do this logic problem, Jane wanted a cat or a dog, her mom said no to a cat, so she asked for, is like inside the prompt, like that sentence probably didn't exist on the internet. But it was able to put things together to accomplish that task in kind of a logic problem. I have an example of this we can go through. Um, Let me give you two high level there's two kind of high level ways I describe the transformer, and most people do. There's one about how its pieces are fit together, um, and how it's actually doing the next token prediction. And then the other way is what is it actually potentially doing? Like, how are those pieces interacting? So at my talk at the AI Engineers World Fair, I actually walk through how all the pieces are put together. I'll show you some of those slides. I call that the anatomy. I use this kind of AI brain surgery, uh, you know, setting or theme. And so we studied the anatomy of the transformer. Then we put it through, I call it virtual MRI to see how it thinks, and then we actually do some brain surgery on it and change its thinking. Oh, and
Could you pull up real quick
yeah,
the illustrated transformer? This is gonna have all the images you're gonna want right now.
yeah. Uh,
And this
I
is written this is when this first came out.
Yes. So this is so actually the so we should back up a second. So first let's define what the transformer is. This next token prediction, which is you get a bunch of text and let me predict what the next token is. That was done by a lot of models, famously called recurrent neural networks. Was the one before transformer.
Markov chains could kind of do it.
And then and then more recently, somebody came up with this architecture called the transformer. And it was actually invented at Google in 2017. We can probably find the paper. So let's do transformer paper.
Well, its attention is all you need. This is where your name or your project comes from.
Yes, exactly. And so they came up with this architecture called attention. The name of the paper was Attention is All You Need.
Bump up that font a whole bunch if you're
Yeah.
gonna look at it that long.
And they came up with this architecture, which if you're not familiar with how it works, this looks complicated.
You need to
But
know what a deep learning neural network is.
well, I would say it's in principle really simple, especially in the case of GPT-2, which kind of cuts off half of this. And really, the goal of my course is to make it where you look at this diagram and you're like, yeah, it is simple. And I think it's understandable even for somebody who does not have a programming background. And so the transformer is the way that was basically what gave rise to GPT-2 and ChatGPT. The high level way I like to describe this is if you let's go past all this, go into the anatomy of our patient here. So it's trying to do this next token prediction, right? Mike is quick, he moves, and like
Faster than Biden.
as a human, he moves quickly, right? That's a fairly fairly logical completion there. But how would we get a computer to do that? Well, computers are really good at math, right? Here's a fill in the blank they can do. 2 + 2 = 4. So
LLMs famously were bad at math. Funny enough.
that is true. But we'll get to why that is in a second. Or we can talk about that towards the end. So the way we do this is we basically take what's a word problem and we turn it into a math problem. In order to do that, we have to do a couple steps. So the first is we have to do something called tokenization. We need to take our words, like Mike is quick, and actually turn them into word units. We actually turn them into tokens, which are subword units. We can talk a little bit about that. So if I take the word flavorize, it'll be broken into flavor and IZE, kind of like the morphemes you might think of, but they don't always map cleanly. And then we take each token and we map those into embeddings. Now here I've shown the embeddings as a single number, but they're in practice a very long list of numbers, and I can get into why that is. And we can see that in the spreadsheet in a bit. And then instead of doing simple arithmetic, we're doing much more complex math, what you've heard of as multi-headed attention, and then a multi-layer perceptron. Multi-layer perceptron, just another name for neural network. We just do a lot of math. And then instead of interpreting this as a one final answer, we interpret the result as a probability distribution. That's this piece called the language head. But in principle, we're basically taking a word problem, taking the words, mapping them to numbers, doing math to turn into a math problem, and then reversing the process. So it's kind of like we take input text, we turn the text into tokens, we turn the tokens into numbers, we do some number crunching on the words. Now, the reason why that number crunching can work has to do with embeddings, which you alluded to. And then we turn those numbers back into text, and then we turn that text into the next token prediction. And I'll just throw this slide up there.
I like this visual and this explanation a lot. This is really good.
Yeah, I'm trying to boil it down. So I have a very strong belief, like if you really understand something, you should be able to explain it simply, up to a certain point. And the simpler you can explain it, the more you're getting to the core essence of it. So this is like my favorite explanation. I have two favorites. So this is one of my two favorite explanations for how it works, or what are the pieces that go together. Now, to understand more deeply than this, we'd have to go through the spreadsheet, and I'm happy to do that.
You're inspiring me to want to take exactly what you have done and do it in JavaScript with just like inputs and React.
Yeah,
you could.
Yeah,
no reason why you couldn't.
Well, it's funny you say that. So my original plan was to do this in JavaScript, and I thought that Excel is more interesting and accessible.
Well, Excel is your native tongue.
Well, both are kind of my native tongue, although I've probably been
I've
using.
seen you code. I've seen you do far more Excel than I've never seen you code
That's
before.
true.
I've seen you do
That's true.
Excel many, many times.
When you're VP of product, you end up doing more spreadsheets than you do coding anymore. There was a day where it was the other way around, but I will say, um, you know, I think the beauty of a spreadsheet is it's accessible and less intimidating than looking at, call it either PyTorch or Python or JavaScript code. But I actually do have a plan to implement this in the web, because some of the feedback I've had is that A, I don't own Excel. B, it has to be the latest version of Excel. Or C, it has
Oh,
to
is it
be
a paid
US
product?
Excel. Well, Excel is you have to buy Excel. Like
Yeah.
the free version of Excel does not work. It's too big. It
Oh,
has
this is
to.
actually I had this question. Could you do this in Google Sheets?
So it's funny you asked that. When I first started this, I tried it in Google Sheets,
Yeah.
and it didn't work. I tried like crazy. I
What
tried.
about Airtable maybe?
Uh, that's an interesting idea. I didn't think about that. Google Sheets. The problem was you cannot get the weight matrix into the. You can't even get the especially the embedding matrix. You
It's too
cannot.
big.
It's
Like, it just
just
craps out.
way too big,
'Cause you can't
right?
run Google Sheets locally.
And you can't run Google Sheets. So I tried all sorts of hacks. I tried actually putting it in the entire weight
Yeah,
matrix
that makes a lot of sense, actually, now that I
inside
think about it.
inside JavaScript, and then I tried to use AppScript to pull it in. I tried to use this. There's a open source like way to connect Google Sheets and AppScript to your GitHub. I tried pulling it that way. I think you might be able to do it if you split it across multiple sheets on a single layer. But like the weight matrices are really big. So we should explain what weights are. Um, so if you look at the spreadsheet, there's 124 million parameters, or weights as they refer to them, inside GPT-2 small, which is probably the smallest model out there. This is what they look like.
And
I don't
so
know if you.
let's be clear here.
Yeah,
So you did not create these weights. These weights were created by GPT-2 being trained on
correct.
data that then they published the weights, and this is what a lot of AI projects now don't publish, and Llama being kind of an exception.
I mean, there's still models like Phi, but yeah, some of the ones most that are household names do
No one
not
cares
have
about
what are
Phi.
referred to as open weights. So you'll hear about, people talking about a 70 billion parameter model or a 7 billion parameter. The most common one people usually fine tune around is a 7 billion, because you can fit it in a small enough card, and it's not too much to work with. It doesn't take as much time to fine tune. But like the parameters are just basically all the inputs when you get your data, right? I talked about this math. It's not arithmetic. It gets multiplied and added and a whole bunch of normalized against all that math. It gets done against basically these weights, and it's just raw numbers, and they're just 124 million of them. This is actually the embedding matrix. So this thing is like 52,000 by 768. It's like, and that's
Wow.
just one. I mean, if you take a look at this thing, you will see weight matrix after weight matrix after weight matrix after weight matrix. It's just this one big massive thing. The most of the work, actually, if you go back to this chart we left off on, is done. Here's the tabs in the spreadsheet. Like entering the prompt is type prompt here, which is what you saw. That's not that one. We'll go to this window. There we go. Oh, I know I did that. So here's a funny story. This is the other reason I want to do it in the web browser. You don't want to run this on the Mac. I have run it on Mac PowerPoint. Mac Excel. In fact, I built it on Mac Excel. And you'll note that I am on a Macintosh machine, but I'm actually running the Windows version of Excel inside Parallels. And the reason is that for some reason this thing is so big, Excel locks up on you in the native Mac version of Excel. So it's another reason I want to build it so you don't need Parallels. Because to run this on the Mac, you need both Parallels and the Windows version of Excel. So it's even more friction. I also want to run it in a web browser because I'd like to extend certain other capabilities. Like I'd like to be able to do back propagation and fine tuning. Those are words describing the learning process. Right now, this is just doing what's called inference, which is predict the next token. But to actually teach it, you need to be able to run those other algorithms I referred to. And I'd actually like to implement those as well into this type of format.
I thought the Mac was built for AI now.
Well, it is, But
Not
the
stupid
MLX
AI.
the MLX guys need to talk to the Windows or the Microsoft Excel guys. I talked to somebody actually when I presented this one place, and I talked about this issue. And I did have somebody who used to work on the Mac version of Excel, and he said, "Well, that thing is probably got bits of Code Warrior. I don't know if you remember that in it, so it probably needs maybe some updates or fixes there." But I was able to get it done. It will run. You just have to. It just will lock up on you. So this is like the high level what the pieces are. We can talk
Apple
about
numbers. That's the
what.
other one you gotta try. You gotta try Apple numbers also.
Oh yes, I haven't tried Apple numbers. Mainly because Excel is just what people know,
Yeah.
and has a greater mind share. But it should be.
So there's
It
also
should
something
be.
called LibreOffice Calc, which is an open source alternative.
I have not tried. Somebody told me they tried it and it didn't work. But that's probably not because of a capability reason, but just the formulas were written for Excel. There's no reason you couldn't do this in any other spreadsheet. I mean, and this is really the answer to that conundrum. If you're first coming to AI, where you're like, how is this code so small? The knowledge isn't so much in the code, right? The knowledge is in the math that you're forcing it to do. It's in these weights that I was showing. Those weights are essentially where the knowledge is. And that's why when we talk about these models, sometimes we talk about their architecture, but more often we talk about the number of parameters, because it's a good proxy for the amount of knowledge it has and the amount of reasoning it can do. So the other way to look at what these pieces are doing, um, that I think is, we're not going to all the details, and I don't think we have time to, but there's another way to look at this, which is as a communication network. So I've got this picture here, which I showed right here. But there's a piece of this that, is really important. It's called the residual connection. So it's basically an addition operation. I can actually show you where it is in the sheet. It's literally just a spreadsheet add. But what's really important about this, and this was really critical to creating very deep neural networks in the early days of deep learning, it lets the model during training decide to route around these two key components in the processing layer. So it can just skip them entirely. And so we can now reimagine the large language model as actually a communication network, as like a communication bus, where it's got this residual stream, which is really just the tokens converted to their numbers. So I can show you what that looks like. So here's the first
Makes me
block.
really wish I knew what a communication bus was. Like I know what it is, but some of the things I never actually got to the point of understanding what the heck it was. It's just kind of it's like your box thing. Data goes in, data goes out. Can't explain that.
How about this? Think about it as just message passing, and people are putting messages on and taking them off. So here's our this is each row
So
here
it's a queue
represents
of
a single
JSON
token.
objects.
It could be. It's more like a stream of them. So each row represents a token. And what's happening is multi-head attention is actually moving information across the tokens, right? So an example of this is if you have this phrase, Mike is quick, right? What it's going to look at is it might look moves. Well, here we go here. He might look at Mike. That's the antecedent of the pronoun. Or moves might look at quick to figure out, this means movement in physical space, because that word quick has multiple meanings. It can mean like movement. It could mean quick of wit, so smart. It can mean the quick of your fingernail, or it can mean alive or dead, like the quick and the dead in Shakespearean English. So because those two are there in the same context, it can say, this is about maybe the word quickly or fast or around, but it's not about like your fingernail. And so it's the job of this attention head is basically, or heads rather, is to move information between the tokens. And then the multi-layer perceptron looks at each token and tries to predict, okay, based on what I just know here at this one token, which has all the information from the tokens before it, okay, what is the next most likely word? And then there's multiple.
That's where you can train. That's where you can train the loss function in terms of whether it was correct or not.
Yeah, you train at the very end and kind of back propagates through all these components.
Yeah, but there needs to be a thing defined as the correct and incorrect answer to back propagate through.
Yes. That's where but that's kind of like, it'll go through all these parameters, and sometimes because of the residual connection, it'll basically skip layers. So you can look at these layers as writing information to the residual stream and then reading it out. And some layers are helping each other and some are not. And they may not be in the same layer. So the example that I like to use is this prompt, which is right here. If today is Tuesday, tomorrow is Wednesday. GPT-2 small can do this. You give it any of the 7 days, it knows what the next day is. And so there was a research paper where they basically went through and tried to figure out what is the mechanism by which GPT-2 small is able to do that. And they found out that there are only 4 components that were needed. Like there's 124 million parameters, there's 12 layers. Of those 12 layers, you only need 4 components in them. You don't even need all the heads. So the way this looks like is it uses the perceptron from layer 0, that's the neural network. It's using attention from layer 9, the perceptron from layer 9, and attention from 10. And they're all talking to each other, and they're kind of doing it slightly orthogonal to what the other layers are doing. But that's how it figures out. Like those working together create what they call a circuit to accomplish this task. So what you can do is there's this thing called logit lens where you can look at every layer. What is it going to predict? And so here we know the right answer is, oh, let me bump up my font. Yeah. So these columns 3 through 9 here are your residual stream. It's your information superhighway. And you can see at the very first block, it's already figured out something about Wednesday, but then it completely disappears. And then later on, it suddenly starts realizing, oh, we're talking about days. So this is where your prediction comes on. It comes on the very last token. And you'll see it's tomorrow, Tuesday, Monday, but it takes a while for it to figure out, oh, the right answer is Wednesday, and then it locks it into place before the end. And that's kind of what we see here. Like it figured out, okay, days. And then later on, layers 9 and 10 kind of pull it up and increase its probability so it comes out and gets the right answer. So that's kind of the 2 explanations I like to have is one, to think of it as here are the components, here's what they do. It's basically doing a math problem, turning a word problem into a math problem. That are fine would be.
You were just lagging for me. I'm not sure if you're lagging on the stream too. Could you stop and say the last 2 sentences you just said again?
Yeah, sure. So those are the 2 ways I like to explain, the transformer. The first is it's taking a word problem and turning it into a number problem. And it's basically just doing very complex math to predict what the next token is. That isn't meant to say it can't do logic or reasoning. It is, but it's to make it seem less magical. And then the second is the explanation I like is to look at it in what's called, this residual stream or communication network or mechanistic interpretable interpretation, which is to say it's a communication bus. And it's basically iteratively refining its predictions using components from various layers that work together, that write information and read information as they together try and figure out what the next most likely token is. Like inside GPT-2 small, there are probably plenty of other circuits. And then something at some point decides this is the right circuit and this is the key one. But this is how it pieces together during training. It creates these circuits to solve various problems. And you didn't have to program the next day prediction in there. It figured it out. And it's probably got lots of other circuits that solve this.
So what's cool about your second explanation is it helps me understand how even though these things like just neural nets in general couldn't do a whole lot of interesting stuff in like the 50s or 60s, there were things they could actually do. Like the very first kind of papers, Frank Rosenblatt was like doing, I don't even know what he was exactly experimenting with, but he was like tuning dials to get to like answer some sort of like math logic problems or whatever. And it's because you only really needed like a couple of layers and a couple of neurons to get it to figure certain things out that hit a ceiling very soon. But you're showing how now we have this giant thing, but it's still distilling things down to like really, really small amounts of information passing.
I mean, it depends on the complexity of what it's doing, but yeah, there are a lot of key components. Like another key component is something called an induction head, which basically, if you say Harry Potter in the sentence, and then later at the end of the paragraph you say Harry, it's going to know, oh, I probably should say Potter. Or there's another circuit that does indirect object identification, figuring out what object, say, you're referring to elsewhere in the paragraph. One way to really drive this home is if you go back and you look at this diagram right here, and you imagine you didn't have these layers in between, right? And it just gets input text, and there's 12 of these as I've drawn here. They call this the zero layer transformer. Like, the best job it could possibly do is doing what are called bigram statistics, right? It just knows every time I see this word, the next possible most likely word is X. And that's just simple probability. I could take my entire dictionary of words and all my text, and I can just say, every time I see the word, so what is the next most likely word? And it might be cute, right?
That's
Or
like
he moved, right?
n-gram models they
Yeah.
used to call those, right?
Yeah. And so what you can imagine is it starts out with having that n-gram or bigram statistic. It just knows, okay, I know what the previous word is. I'm going to predict that. And then each layer is kind of trying to refine it by additional information from all the other words before it to make it even more sophisticated with these more complex circuits that go beyond just having an n-gram,
Well, I remember reading examples
calculation.
from like n-grams, and it's like you read it and you're like, it's kind of like a person who's like really like confused and on drugs and like sleepy, because it almost is sentences, but it's not quite,
Yeah.
because it's like fragments of things that kind of make sense, but it doesn't all hang together. And that's where we
Yeah.
got now, is that it all hangs together. It has a global understanding in a way where all of the tokens can have some kind of coherence.
That's a really good point. One of the key things, which we didn't have time to go into, about attention, is that it looks back. A classic n-gram only looks back n words, right? But attention is allowed to look at every token before,
And
right?
that's
And
why
figure out.
attention is really the breakthrough here.
Well, the idea of attention already existed, but the idea of saying you only need attention plus the multi-layer perception, that's really all you need. And you just do that over and over. That was the really surprising finding. And you can actually see a little bit of this inside the spreadsheet. So if you go to this one and you go to, let's see, where is this? Block 0. I reran it with here. I'd have to rerun it. Let's rerun it, and then we can talk about something else. But Mike is quick. He moves. He does not move cute. So we have to recalculate this, and then we'll see our result. But you can actually see the attention pattern inside each block. Now there are multiple heads, and there's a lot of ways. But you can, when in this particular example, you can see he looking at Mike in its attention scores. So that's kind of a quick crash course in transformers and how they work. And my goal in this course is really to demystify as much as possible. So I've launched this course where I'm basically going to demystify how transformers work. Every single step of the model, I'm going to just go through each part and try to explain as simply as possible, even if you're not a developer. But I think it really helps if you are a developer. You can kind of watch
Yeah,
the
you have
sample
a
intro
hard
video.
time understanding
Yeah.
this. Nice you got Jeremy Howard on here, by the way. And
Yeah.
this segues into kind of one of my last questions, which
Yeah.
is, I think I know the answer to, which is that this is a learning tool. You don't really expect anyone to like use this to do serious work, at least not today. Maybe it could kind of turn into that, but I think right now you seem to be gearing it as a learning tool, and I think that's really cool, because it's rare that I see people build like a large complex, even it's not that large a complex, but like a built out kind of thing that is just meant to like explain a thing to people. Like, this is my whole deal. This is like what I do. This is why I love building stuff that explains things. And this is like such a brilliant way of explaining something that no one would have thought of until you did this, I would imagine. So yeah,
Uh,
like
I
go
wouldn't say
ahead.
no one. I think Jeremy Howard, was an inspiration, gets a lot of credit. He uses spreadsheets, but he uses it a lot in his examples, and that was kind of the inspiration. But he doesn't do the whole entire language model. I wanted to do something that was not a toy. I wanted to show that, just this true next token prediction as equivalent as GPT-2 is really just a large math problem, and I can take you through every part of it, and I think it's all understandable, even if you don't have, a machine learning degree or even an engineering degree. I think there are ways to explain even things as simple as or as complex as embeddings to make them approachable, and that's something I've tried really hard to do inside this material.
Good. Well,
To
Jeremy
answer
Howard
your
is the one and only person to scoop you. I'd say that's still pretty good.
yeah, I suppose if you're gonna if you're, yeah, exactly. I'll take that.
I never took his course. I always knew I should have, so I would have known that if I actually took his course.
Yeah, he has a, the part of his course that where it clicked for me was he does actually I think it's like a convolution of basically an image. And the image is a spreadsheet zoomed out. So each pixel is really just a cell. And I was like, "Oh, wait. I wonder if I can do this with a language model." So, to answer your question, yes and no in terms of a learning tool. So yes, it is a learning tool. I think of this in terms of horizon planning. So I don't know if folks are familiar in product management. You plan for like right now, then the future and the present, or things that are going away, present and the future. The current horizon is a learning tool. Um, I do think this idea like spreadsheets are all you need, that phrase captures something for me more than just simply the parody or play on attention is all you need. I'm well known for this view that, saying at work, I think a lot of SaaS applications, maybe not all, are isomorphic to a spreadsheet at some point or
Mhm.
another.
The Rails
And
app is
so,
a spreadsheet.
yeah. So I do think there's potentially an interesting avenue, which I've not quite figured out, where
So
you
this
could
is my
use.
other
Yeah.
question was, did would this be once you build it into something that's gonna be a useful tool, would it be for AI people who want to do Excel stuff or Excel people who wanna do AI stuff?
Um, More the latter, but I honestly wouldn't phrase it that way.
Okay.
I think there's two use cases. One is I think um, a spreadsheet is or a table, I should say, or a spreadsheet-like interface. I think spreadsheet has a lot of connotation. Um, is a natural interface for interacting with a spreadsheet at a power user type level, where you may want to be iteratively refining a prompt, or you might want to give it a bunch of data to fine tune and see the results and measure it against some evals. So I think it's a great way to work with maybe even API for a large language model. Um, I do think there is, just like Canva, if you showed that to somebody who uses Photoshop, they'll be like, this is a toy. I do think there is potentially a future where people might be building or tweaking models inside a spreadsheet-like interface or interacting with them. I don't think we're at
And
that
there's
yet.
no Copilot for Excel yet, right?
There is actually.
Okay.
It only
I
works with
see where you're going with this now.
Um, I do think there's a really interesting space, and I don't think I'm the only one to say this. I have a list actually I'm categorizing of keeping track of all the spreadsheets meet AI companies. I think there's definitely fertile ground there. But for now, it is a teaching tool. But I do hope to build this inside a web browser so more people can use it, both to learn, but also to see what potential there is for when you combine the two together. I
Let's
think that's a
build
really
it
powerful
on stream together. Let's do it.
Oh,
I'm so
I might
down.
take you up on that. Yeah. So,
Yeah.
but right now, look, it's a teaching tool and it's a course.
Yeah,
And even
I
if
think I
you
cut
don't
you
know,
off earlier when you were finishing a thought. Did you have anything else you were saying before I segue to that question?
I think the only other thing I'll just say on the course is like, even if you don't own Excel, I spend a lot of time. You can look at, for example, like the sample classes I have posted here. I spend a lot of time making it as simple and easy to understand.
You could write this on
Uh,
paper. Like,
You could do it. There are people who've actually
yeah,
posted doing it on paper.
yeah.
But my goal is to make it as approachable as possible. I think, in today's world, it's like when computers first came out, in the 80s, you had to know basic things about how they worked. They were binary, what a megabyte was, what a, kilobyte was. When the internet came out, people, or the web rather, you need to understand trumpet windsock and all these other things, which some of which you don't need to know, but you still need to know about like bandwidth and other concepts like that. And so I feel like, you know, it is useful for almost anybody to understand and demystify how these tools work if they're, say, a power user, and especially if they're trying to figure out what are the limits of what these things can do, so you can have a conversation with, say, your engineering team or other stakeholders who are actually building, your AI engineers. And so that's why I think I'm trying to make it as universal for everyone.
Awesome, man. This was I knew that I was gonna come away from this conversation knowing a lot more about Transformers than I did going into it, and that's exactly what happened. Your slides are great, by the way. What
Oh,
is
thank
your
you.
talk probably isn't online yet, but it will be, right?
My talk actually is online.
Definitely.
Um,
Pull that
it
up.
Yeah, but you have to go to the 7 hour and 44 minute mark of the live stream in
Just
YouTube.
get a you could just get a URL with that
Yeah,
timestamp
you
in
can get
there.
a URL. I can send it to you, but I know they're going to break it up and post it as separate ones, but I can send you the link that
Gotcha.
goes directly to it. But it was a keynote stage talk, so the keynote stage was recorded. They've recorded everything, but they live streamed the keynote plus a few other tracks.
Right.
So, and it's not a very long talk. In fact, if you watch on double speed, it'll actually be less than 10 minutes. I think it's about 20 minutes long. But there's obviously a lot more detail that I go into inside the course. So
Sweet, man. Anything else you want to talk about, or things that you're interested in AI that you think people should be paying attention to?
oh, there's no shortage of things in AI that I'm interested in. I'm most strongly interested in, this field they call mechanistic interpretability, which is about figuring out how these models actually work, as well as bridging uh, you know, these models to actual problems that can be solved. Basically, the job of the AI engineer. I'd call it the AI product manager is, AI is not a product, right? And so how do we actually turn these into reliable, useful things like cars are today? And so those are the two areas that I'm most interested and fascinated by, AI product impact and how they actually work under the hood. For other people to stay, focused on, I would just say there's so much, but my big recommendation is something I call the AI step count. So just like you have like, you try to get 10,000 steps in, there was this Moderna CEO who did a deal with one of the large language model providers, and he said, I expect my employees to use this 20 times a day. And so pick a number. 20 is not a bad one. And try to remind yourself to use it. I have been at work and I was like, oh, halfway through, I'm like, I could use GPT for this or Copilot, which we had at work.
Yeah,
And
welcome to my life.
yeah,
All day, every day. I have GBT open more than any other tab.
yeah, exactly. And so I think my recommendation is to folks just remember to try it. A good example of this is like LinkedIn maybe slightly overdoes it, but if you're in LinkedIn Premium, there are all these little sparkles suggesting you should write that message with AI or summarize this long post somebody put with
That's
AI.
why everything on LinkedIn sounds the freaking same, like they were written by bots.
Well, social media in general may have that problem, but the point is, you have to remember right now to use AI because it hasn't become like electricity built into all our workflows.
Because they're
And
not
the
hanging out
best
with me
AI,
enough,
what?
obviously.
Yeah.
So they're not
Well,
hanging out with me enough.
well, that's true, but I'd say for most people, and coding is
Yeah.
a big exception. Coding
Yeah.
is one of those use cases that lots of people, it's one of the fastest adopted use cases. In fact, if you look at, I was just chatting with someone online, and it was like, which AI companies have the best, outside the model providers, and SourceGraph had really impressive growth numbers, and it makes a ton of sense because coding is one of the most common, most useful, most testable use cases for AI models. Plus, it has a direct tie to productivity. So they've had some great they can point to revenue in a way that I think other people are doing POCs right now. I still think that revenue will come. But yeah, I'm not surprised to find you use it. Like any developer is probably using it more than 20 times a day. That's really a challenge I'm giving to people who are not developers.
You know who's not? Fuzzy Bear. Fuzzy Bear's a total LLM hater. He
I,
actually came
I
on the show to talk to us about it. So like totally respect his opinion. It's good chatting with him about it, but he's definitely one of the people who is not feeling the need to use it every day. So
I would love to chat with Fuzzy Bear either on a future live stream or offline, or
yeah,
I'll watch his episode.
yeah,
I
for
always
sure.
like to hear both sides. So
Yeah, and so your course is it live? Can people use it
yep,
and buy it right now?
they can use it. It's going to be a live course. So it's going to be the last week of July, starts on July 29th, goes
Oh,
3 days.
that explains why these courses can be so expensive.
Yeah, they're live cohort driven. That's how Maven works. So you get
Right.
live interaction. It's not a recording.
Actual teaching is what you're
Actual
saying. You
teaching.
need to literally teach.
Yeah. I care very deeply about, good explanations and teaching. So I really actually want, you can do a pre-recorded course, but especially for this first one, I wanted to have that interaction. And I'd actually done a course on Maven recently that I thought really great interaction there. So I want to replicate as much of that as possible. So that
Could I
starts.
get in for free if I'm your teacher's assistant?
We can, yes, we can work something out. Yeah.
Okay.
So it's at the end of the month, and then if people miss a session, it will be recorded. But that's the plan.
Cool, man. Well, this is super legit. I'm so glad that you have also been like, well, web was fun, but guys, AI.
Yeah, well, I think like everyone,
And we're
there's
both wearing Redwood shirts,
yeah,
like one
we're
of the
both wearing
greatest web
redwood. Yeah,
frameworks ever. So it's
that's
not like we're anti-web now. And that's why I'm building out like a web thing. Like I'm building a full stack app. That's just totally like I'm living the AI engineer lifestyle right now with
yeah. Do you
Auto
want to talk
Show.
about
So
auto show?
you're one of the so I think you were the second person to ever use Auto Show. I ran
I
your
think so.
first
Yeah,
3 videos
yeah,
through it, and you're like, "Wow, these are really good." And I'm like, "I know, right?" So, Auto Show is a tool that lets you use different transcription models, either locally or hosted, to transcribe a video or audio file, and then concatenate a prompt that is fed to an LLM, also either local or hosted. It has 5 different options right now. And you can tweak the prompt to essentially let you generate all sorts of different content from the files. It was originally for me to create show notes for FS Jam because I wanted to have chapters with timestamps. I wanted to have a nice description and summary. But now, like, I was talking to one of my friends just last week. He's a teacher, and we were talking about, and I realized that I could take like a video he wants to show his class, feed it to Auto Show, have it create 10 questions for the teacher. And it's just a slight tweak in the prompts. It's like all of a sudden now it's not even just for content creators. And it's so yeah, like my mind continues to expand in terms of what it can do. And I feel like I'm building it out in a way where it's like very flexible as long as you have just like enough, node experience to like know how to run some node commands. And eventually you'll have a front end which is input form. So it'll be for anybody. But yeah, it's been super exciting. It's like the most hyped I've been on. This is the first like real useful open source thing I've ever built. Like it has 20 stars, which is not a lot, but it's like 19 more stars than any of my other repos. So yeah, it's like I've learned a ton building it. I feel like I'm doing a legit open source thing finally, and it will eventually become a product that will make me maybe not a lot of money, but some amount of money. We'll see.
I'm hugely excited for it. Look, the ability to content repurpose in ways we couldn't imagine is one of the great use cases for LMs. I like to call it taking unstructured data and making it structured. I'm really hugely excited for it and looking forward to what you do with it.
Yeah, there's only 50 companies doing it, but I feel like none of them give you enough configurability and enough low ends to actually mess with the different models and tweak the prompts. And like they give you like you can use our summarize
Yeah.
API that gives you crappy summaries. And like if I just ask ChatGPT to write a summary, it's better than what this whole company is giving me.
Yeah, I mean, there's an extent to which the frontier model providers are accelerating so fast that other solutions it's hard to keep up with
Mhm.
what you can do just throwing it at one of these frontier models.
And I'm built so
Um,
I can switch out frontier models. So I can go from ChatGPT to Claude, and if Cohere all of a sudden takes the lead, you can switch to that. It's just a single flag you throw the CLI.
the other thing you're reminding me is just um, like when I first encountered various forms of development in my career. I can remember React. I can remember JavaScript. I can remember C
You
programming.
remember JavaScript? You're old.
I am. But you come across something and you're like, I feel an urge to build, like an intrinsic urge
Mhm.
to build. And I would say, generative AI is definitely giving me that as well. I think it's very inspiring it's rare you only get these every once in a while where a tool comes along and you just can't wait to build on top of it. And I think that's what I'm hearing from you. I think that's partly what a lot of the excitement at the AI engineering conference was also about as well.
I love that, man. That is so just be so hyped. Hey, it's a good place to close out here. Just give your Twitter so people can follow your tweets.
Yeah, my on Twitter I am at IANAND. So my first initial plus my last name, all concatenated together. That is my Twitter handle. LinkedIn, I'm also posting as well, and you just look for Ishan Anand, and you'll find me there as well. Those are the two
And
places.
you're open to be hired.
Yes, I
For
am
the
around.
first time in what, 15 years?
It's yeah, as a co-founder, I am very interested in doing more AI stuff. So yes, I am around. Let's put it that way. Yeah.
Awesome. We should definitely do more streams.
Yes.
All right. Thanks everyone for watching. Thank you, Fuzzy, Mike Cavalier, who was also on the show and had a cool AI project for generating children's stories with different
Ooh.
topics and age groups. And Nate Codes. And do you know Aiden Amavi? Is that one of your homies?
No, I don't.
Yeah, I don't know who that is. They had
Okay.
I found a website for him. I think that was who it is. So anyway, some random Twitch person is watching. So thanks everyone for being out there. Not sure when the next episode I'll do, but probably in a week or so. I'm back from vacation, ready to do things.
Thank you.
All right, bye everyone.